Hello everyone, welcome to my YouTube channel. Today I'm solving Leetcode question 695, max area of island. First, let's try to understand the problem statement. You are given an m times n binary matrix grid. An island is a group of ones representing land, connected four directionally, horizontal or vertical. Remember, it's four direction. You may assume all four edges of the grid are surrounded by water, which means the edges of the grid are surrounded by water. Means that, for example, given a grid, you can imagine outside the boundary there are all water. The area of an island is the number of cells with a value 1 in the island. Return the maximum area of an island in the grid. If there is no island, return 0. So let's try to understand the problem a little bit better by going through the example. So in the example 1, we have this grid like this. So now let's check how many islands it can form. So the first island is this one. So it has area 1. Second island is this one. It has area of 4. Third island is this one. It has the area of 1, 2, 3, 4, 5. And then the fourth island is this. It has the area of 4. And then the fifth island is this one. It has the total area of 6. And then this one has the total area of 5. So in this case, after comparing the area for all the islands in this grid, so we find out the maximum area of an island, which is this one. So it's highlighted in orange. So it has a maximum area of 6. So that's why, in this case, given the input grid, our output is 6. Remember, it's very important to understand the four direction, horizontal or vertical. So in this case, this island itself is a standalone island. It's not connected to the island below it because they are not connected in the four direction specified in the problem statement. So pay attention to if it's 4 direction, horizontal or vertical, or if it's 8 direction plus diagonal. Cool. So the edge cases, let's say, if we do not have any island in this grid, we just return 0. Okay, so now we understand the problem. So how to solve it? You may find it very similar to the number of islands we solved before using the depth first search. So remember, when we solve the number of islands, we want to count how many islands are there in the given grid. In this case, we are trying to find the maximum area of all the islands in this grid. So in this case, we need to keep track of the area for each island. And then every time we find an island, we compare its area with the maximum area that for all of the islands we have traversed so far, and then update the maximum area if necessary. In this case, after visiting all the island cells or all the cells on this grid, basically traverse and find all the islands on this grid, we get the maximum area. So yeah, this is the solution. So basically, we can see that we build on top of the idea we had for solving number of islands and just utilize the additional variable to keep track of the area of an island, and then also the maximum of area of all the islands that we have traversed so far, and just keep updating the max area as we traverse more islands. So now, what is the time complexity? So the time complexity is O m times n, because we traverse through the cell on the grids. And then what is the space complexity? So what kind of additional data structure we need besides this grid? So we need to keep track of all the visit cell, because remember, in depth first search, we do not want to repeatedly visit the cell that already visited before. We can choose to utilize a set to keep track of that, or we can choose to modify in place and mark the visited cell using a different number. So that's what I'm going to do in that case, my space complexity will be O1. So in this case, let me write down the main idea for solving this problem. So the approach is DFS, and then the time complexity is OM times N, and then space complexity is O1. So now let's start coding. So Mn is the dimension of this grid. Let's have a variable maximum area initializes to 0. Basically, utilize this to keep track of the maximum area of all the islands we have traversed so far. And then we kind of do the DFS. So before coding the DFS, let's just code up the traversal. For I in range M, for J in range N, let's say if grade I j equals 1. So in this case, we call our DFS ij. So remember, every time when we find an island, we want to update the area in this case. So basically, before we start traversal, we initialize a variable to keep track of the area. And then after we traversal, now we just assume that this area got updated while we are updating the DFS and traverse through all the cells belongs to the same island. So after finish traversal, we got one island. And then in this case, we just compare the maximum area with this area. Let's say if this area is larger than the maximum area, we just update the maximum area. And then in the end, after we finish traverse all the islands in this grid, we can just return the maximum area. So now it's time for us to code this DFS function. Basically, we want to utilize this DFS to traverse through each island. So in this case, if it's outside the boundary, we just return. So if x less than 0 or I greater than m minus 1 or j less than 0 or j greater than n minus 1 outside the boundary, or we have already visited this one. So let's say we already visited this one. Which means when we already visited one, this utilize, let's say we utilize a negative number, minus 1. So now assume all the visited cell has already been marked as number 1. Or this one is not an island piece, so it's just water, then we don't want to continue with it. So in this case, we just return. So let's say, okay, now we kind of like want to start visit this cell with index as ij. In this case, we first mark it as visited. So we mark it to minus 1. And then we check all the 4 directions. So for new x, y in the 4 directions, I plus 1, j, I minus 1, j, I, j plus 1, I, j minus 1. In these 4 directions, we just call DFS x, y. Okay, now we just implement code for traverse through the island. So what's missing from this? The area. How do we keep track of the area? So let's say, okay, before visiting each island, we initialize the area to 0 outside of the DFS function. So now within the function, we want to declare this as non-local. And then every time we visit the grid cell with indexes ij, we want to add 1 to the area. So that's kind of how we update the area. So in this case, we just finished coding the problem. So let's try to run the code. Okay, it passed the first test case. Let's try to submit it. Okay, cool, awesome. So let's try to go over the code one more time. So remember, we utilize the maximum area to keep track of the maximum area out of all the islands we visit so far. And then we just loop through this grid, trying to visit every island cell on this grid. So if the grid ij equals 1, then we start visiting and then we will finish visiting until we traverse every cell belongs to the same island. So before we start visiting, we just initialize the area of this island to 0. And then we will just update this area while we traverse through every cell belongs to this island. And then in the end, we just update the maximum area by comparing the area of this island to the maximum area of all the islands we have visited before. So now take a look at the DFS function. It's pretty standard and similar to how we implemented the DFS in the number of islands. The minor difference is we are keep track of the area and then update it. So basically, we declare first as a non-local variable area. And then every time we visit a cell, we add 1 to this area. That's kind of how we keep track of all the area and keep updating it. So that's the end of my video. If you like my video, please don't wait to subscribe to my YouTube channel. Thank you.